Alright, let's just go through some quick definitions before we get started. This is Circles, Chapter 6, 6-1. There you go, 6-1. Alright, how do we define a circle, buddy?
A round object.
Yeah.
That's the whole 360 degrees.
Good
Okay,
job.
makes 360 degrees. A set of points.
Good job. Forever.
Equidistant.
Equal who?
Equidistant
What's that mean?
to a given point. Equidistant means each point is the exact same distance away from a point as every other point.
So they're all even?
It's an equal distance.
So like the center of a circle out to the edge of the circle, no matter where you go from the center to the edge, all of those will be the same distance from the center to the, all the radii.
So they're all even.
Yeah, that's what equidistant means.
Oh, I get it. What is the need for a big word?
So I don't have to use a paragraph like I just did to explain what I'm saying. All right, radius. You can tell me what a radius is.
Okay.
The measurement of the inside of
A little more specific. Ransom.
Half of the distance from the middle of the circle. It's like half of it.
All right.
From the middle.
How about this? A line from the center of the circle to the edge. From the center of the circle to the edge of the circle. That's a radius. All right. How about diameter? You can tell me in these kinds of words what a diameter is. Yes.
the distance across the circle.
Yes.
That goes through the midpoint.
That goes through the center. Because you can go across the circle without going through the center. That's called a chord. But we're not talking about that. All right. So a line from the edge, from edge to edge, through
When it's saying, oh,
the center.
Extremely exact, but gets the job done.
Alright, so it's extremely important that everybody in here understands what a radius is and what a diameter is. Because there are a few in here that struggle with that. A radius is half of the diameter. The diameter goes from edge to edge through the center of the circle. And the radius goes from the center of the circle to the edge. It's half as long. You need to know that for your calculations. Circumference. Can you tell me what circumference is? Yeah. The perimeter of a circle. That's a good way to look at it. Think about it. It's the distance around a circle. So instead of saying perimeter, when we ask for the distance around the circle, we call that circumference. It's just a fancy name for perimeter. Okay? Now, right there. Sorry. dirty circle.
Is there a
Here's a
need
circle.
for an awkward part?
What? This is called a rotor.
I don't know.
You shouldn't care because you're going to be doing stuff with this here in the next few weeks.
Why?
So this is what stops your car. It's kind of important.
Very.
Okay, notice it's shiny right here.
Yeah.
And the rest of it's dirty because this, to tell you what it does, you have two braking pads that go around this. That when you step on the brake pedal,
Second bite.
it squeezes it together, and as the wheel's turning, it slows it down. So that's what stops your car. Now, what we have here is a whole bunch of circles. We have an outer circle, an inner circle, and another little circle in here, a bunch of little circles that your bolts go through to attach to the tire. Okay? And this is called a surface area. We're going to be doing surface area here in the next few days, and we got to understand exactly how much surface area it takes to stop a car. Okay, and why not just make it the whole thing? Why not make it bigger? How they come up with this amount? So it's very applicable to understanding your circles, your surface area, and your volumes. Yeah.
How did you get that?
Took it off the car.
Took it off your car.
He stole the car, that's what happened.
Now new ones are very nice looking, baby. They all look like this all over. But I wasn't gonna bring in anyone.
Was
Yes.
it a car no one was using?
It was off my truck, yes. Because I had to put new ones on.
Really?
If you notice, if you look closely at them, it's kind of ribbed a little bit. It's not exactly perfectly flat. It's got bumps in it, and it's indented into the metal. So it was kind of getting worn, so we need to get new ones. Okay? Because it makes the car shake when you brake. If it breaks and this isn't perfectly round, perfectly flat, it causes it to shake. You feel vibration. Well, you might need some new rotors.
And I can never go to sleep because it's always vibrating.
All right, so we're going to be dealing with this throughout this week. All right? And you will be actually doing measurements and stuff. I have some other rotors back there and some other things. All right, so let's actually talk about a couple of things here. Example 1, we're going to talk about circumference. So find the circumference when the diameter is 6 centimeters. So, I want to give you just a brief explanation of what circumference is and what they used to do. So here's a circle. Oops.
Good job.
Try it again.
That was fantastic.
So there's a circle.
That's not
You
a
better
circle.
go do it.
It's like always perfect.
All right. So if I had a string that went from one edge to the other through the center,
That's
okay?
not very interesting.
Let's say I had a string that was the same distance as your diameter. Okay, so that's the diameter, right?
Yeah.
And half of it is?
Radius.
Right. Let's say I take the diameter and I lay it across the circle. I get about 3 of them to go around the circle, right? Alright. If I actually had it, it would do about 3. But you have a little bit left here. Okay? Well, the distance around, they used to say that the circumference was just 3 times the diameter. This is history for you. So we're not going to actually use 3 times the diameter. It's a little bit more than 3. Can anybody guess what that is?
3.14.
3.14. That's the extra little bit that's missing. So that's where the history of pi came from. So circumference is pi times your diameter. So if you need a calculator, get it now. And somebody tell me. Hurry up.
Hey, Brandon, move right over here.
Yes, that is mine. No, it's mine.
It was up there. I like pie. I like pie.
Devin, accidentally hit this and went boom.
basic problem, Hannah.
Is that the time? Is that the time? correct?
Yes. Well, two answers. One, on my calculators, it has a pi button. So Jesse's gonna actually use the pi button. Okay?
Wait, I gotta find it.
Do we have to use the pi button?
Hold on. I'm gonna show you something here.
Just pi makes it.
Oh.
Oh, never mind, found it.
Seriously?
Take that times 6, please.
Times
What do you get?
Oh.
18.6.
Shut he what? Is your name Jesse?
4.
9555592.
Didn't get that much.
Okay, and Quentin, did you use just 3.14?
Yeah,
What'd you get?
18.84.
That's it?
Yeah.
Okay. So notice that they're very close together. I would rather you use the actual pi button, but it's okay just to use 3.14. That just means everybody's going to be a little off. So to keep everybody the same, please just use 3.14. So you actually type in 3.14 when you're multiplying by pi. Neffy.
You don't round up.
Yeah. If you use this, if you use the pi button, you would have told me rounding to the nearest hundredth would be 18.85.
Okay.
Okay? So let's all do the same and just use 3.14. Alright? Alright, so let's do example 2. The radius is 3 yards. I want the circumference. Circumference is pi times the diameter. So,
Seriously?
That's very easy.
yes. So Jose, what do I do first?
Times the radius by 2.
Why? Why do we multiply the radius by 2?
Because the radius is half of a diameter.
Yeah, what are you doing?
He's talking.
Stop talking. So, what did Jose just say?
18.84.
Why? Why is that?
Because the radius is the diameter
Yes. Alright, because we need the diameter here. Alright, so 3.14 times 6, and we get what we had up above.
18.8.
Make sure when you're doing your homework tonight that you read the directions of where they want you to round it to. Okay, this is to the hundredth position. Let's do some other business here. So what? Alright, example 3. The diameter is 7 inches. So I'm going to call on somebody to give me the answers. Everybody work it out.
You know, last year, Circles irritated me, and I hated them with a passion.
They're so easy.
Okay, Addie, what did you get?
21.98.
What if I said round out to the nearest 10th? What would you get, Branson? What? 22.0. And you do want to say 0.0 just because that makes everybody understand that you had rounded it to that position. And they don't think it's exactly 22 that way. Alright. Okay, yes, Hannah.
This for like inches.
Yes, you need to put the units down. So, inches, what do we have over here? Centimeters and yards. Okay. Example 4. I want the area. Area of a circle is what formula that you all should have memorized?
Pi times radius squared.
Pi times radius squared.
Oh, yeah.
How did you know that?
Because.
Pi r squared is what we say. Pi r squared. What do we do first, multiplication or exponents? Make sure you do the square before you multiply by 3.14. Alright, so example 4, the radius is 4 inches. Everybody figure out what the area of the circle is. Faith, what'd you get?
50.24.
Is that correct? Alright, 50 point what?
24.
And this would be square inches. Length is always just the units. Area is the units squared, and volume is units cubed.
Yeah.
Okay, 3.14 is pi, and you multiply it by 16.
Oh. 6.
4 squared is 16. 16 times 3 is 48, so I knew it had to be a little bit more than 48. Let's try another one. Okay, example 5. The diameter equals 10 centimeters. So if somebody just tell me what the first thing is you're supposed to do, raise your hand. Yeah. Why? Yeah, you have to use the radius, and the radius is half the diameter, so the radius is 5.
Wait.
Yeah, what do we-
What was this?
We're doing the area.
We're doing the area.
I
Just
missed
to
that part.
15.7.
All right, everybody check that. So the area is pi r squared, 3.14 times 5 squared, 1.14 times 25. And what'd you get?
15.7.
Well, 3 times 25, you forgot to square your 5. Can't. 78.5 exactly? 78.5 square centimeters. Everybody get that? Awesome. Alright, so here we have this rotor, and I want to know the area of the shiny part. So, example 7.
6.
6, sorry. I actually have another one on my paper, so.
Doesn't count as a mistake.
Oh.
No, it's not a calculation mistake. So here's your rotor. I want the shaded part here. This part is 2 inches. The radius is 6 inches of the whole circle.
Oh.
So, I want to know how you find the area of the donut, basically.
And
It's a
what's
big
the
donut. Huh?
But what's the 2?
The 2 is how wide the shiny part is on the rotor.
Oh my goodness.
So basically, how do you find the area of a donut? How do you do it? I want to know how you do it. I don't need to know the numbers right now. Quentin, how do you do it?
What'd you do, 6 times 6?
I don't want to know the numbers. I want to know how you solve the problem.
You find the diameter of the circle in the middle, and then you find on the outside and subtract the middle from that whole thing.
Not diameter. What you're saying is correct, but it's not the diameter you're finding. You find the area of the whole circle, and then don't you subtract the area of the center circle?
Yes.
And then what you'll have left is the shaded area. So you need the area of the whole circle, we'll call it A sub 1, of the outer circle. This big thing, the area of the big thing. So that's going to be 3.14 times the radius squared. The radius of the bigger outside circle is 6 inches. So you got to square that, multiply by 3.14. Everybody check that and make sure that's right. Is that correct? All right, now we need to subtract the area of the inner circle. The inner circle is pi, 3.14. What's this radius then? 4, because you subtract off this 2 right here. So this would be 4 inches. So I want the area of this center circle. So, or we already did this, right? Yeah, example 4. So that was 50.24 square inches here. So what is 113.04 minus 50.24? Adding. 62.8.
Yeah.
So you took the area of the big circle, minus this center part, you took away this center circle, and that left you with the shaded region. That's how you do that. Example 7. You have a square. And it is a 6 foot by 6 foot square. And in this square you have 2 half circles that are identical. Now they are. Right? Close enough. Right? Alright, so 2 half circles, back to back. I want to know the area of the 2 half circles put together. What are 2 half circles put together? So we're just finding the area of a circle, right? How do I know that these 2 halves make a perfect circle?
Because you
Sides. Well, yeah, because you said so. On the sides, it looks like it's in the middle of them.
Yeah, they're in a square.
Because this is a square. So
Diameter
the radius on this circle is the same as the radius on that circle.
Good job.
Okay? What is the radius? Devin.
3.
Yeah, the radius is 3. If this is 6,
Oh, I
and it's a square, then half of this is 3.
I do it before.
So the area of this circle is 3.14 times
6.
9. 3.14 times 9. What do you get?
28.
I do that before. Oh,
Yes, you do.
Feet squared.
I give up. I can't.
Exactly, like, I don't get no side.
Oh, my
I mean, they already had the
Hold on.
answer. That's what you said.
Ha.
She already said it.
Maybe that's why I'm in art science, but I can't draw.
Assignments.
I came out of art class not being.
Page 264. 123, 30, and 31.
No.